All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 9.1 in Pre-Calc, which is on page 614 in the textbook. So this is sequences and series. So the first thing we're going to do here is do a little bit of vocab and talk about the difference between a sequence and a series. So let's start with sequences, right? So we're going to start by talking about sequences. So a sequence is a list of numbers separated by commas, right? So an example of sequences, so a sequence is a list of values separated by commas. All right, so, sorry, inching over a smidge. So let's do a couple of common sequences, right? So 2, 4, 6, 8. That's a sequence, right? It's 4 values that are separated by commas, right? Sequence 1, 1, 2, 3, 5, 8, 13, is a pretty famous sequence. This is actually the Fibonacci sequence, which we can talk about in a minute. So that's a sequence, right? Again, a list of values separated by commas where the values do have an order, right? So this 2 is the first value in the list, right? I can't switch the 4 and the 2 and have it be the same sequence. So to be clear, the sequence 2, 4, 6, 8 is not the same as the sequence 4, 2, 6, 8. So the numbers are a list, and so if it's easier to think about it this way, it's an ordered list, right? Like the order of the list matters, right? Like whatever the first term is the very first term. Okay, so each one of these things is called a term, right? So these values are actually called terms, okay? So it's a list of values or terms, right, that are separated by commas. So if we wanted to give a generic definition of a sequence, right, a sequence could be a sub 1, comma a sub 2, comma a sub 3, comma a sub 4, all the way up to like a sub n, right? So in this situation, a sub 1 would be the first term in the sequence, right? And a sub 2 would be the second term in the sequence, right? And the third term and the fourth term and so on. And when we get to a sub n, that would be the nth term, right? So if it was a sub 100, it would be the 100th term, right? Comma, . Now, what I want to talk about next is these ellipses, right? So both of these are examples of an infinite, I can spell, infinite sequence, right? So each one of these is an infinite sequence, right? So this is what we would call a finite sequence, right? It only has 4 terms, right? So you could have a sequence with a whole lot of terms. Like you could have a sequence with like 100 terms and it would still be a finite sequence. But this ellipsis at the end, right, means that the sequence goes on forever, right? Now, it might go on forever in a foreseeable pattern, right? In a pattern that we could actually figure out. It might not go on forever in a foreseeable pattern, right? It might go on in a completely random, irregular pattern, like not a pattern at all, like a completely random list. But a sequence that has an ellipsis at the end is called infinite. So each one of these is called a term, right? So each individual one of these is called a term. So essentially, that's the way our sequence works. Now you'll notice that these numbers at the base of a sequence are all counting numbers, right? So natural numbers are counting numbers. And the reason for that is you can't have like a 1.5th term. Like there's a first term and there's a second term, but there's no term in between. They're counting numbers. So that's sort of the idea of the basics of how a sequence works. So that's, again, an intro to a sequence.